So as John alluded to, we're going to be talking about automatic water cannons, and specifically automatically operated self-targeting monitoring systems. So these are monitors that are designed to operate automatically. They typically consist of some form of detection. It can be an optical flame detector, thermal, video detection, or a combination thereof. There's a monitor, as you can see, that's viewed, that's typical of firefighter operations or in the oil and gas industry. There's electric motors on that monitor that actually will change the deflection, elevation, and even the stream. It can be straight stream, or you can open it up for a fog effect. And then there's a central control unit. So you're taking that detection piece, you're potentially triangulating, or there's a human involved to actually steer, target that fire, and suppress. It was about 15 years ago when I first started working on a system with the Royal Navy. I think we did a presentation, it was either SFPE or it might have been SFPE, where we used 2 video image detection systems to triangulate and then deflection, elevation, suppress. Probably about 10 years ago, I worked with some students at University of Champaign, Illinois, that made a smaller tank system that had a thermal and targeted and was more for room suppression. Those were all kind of research projects. Now it's good to see that there's actually commercially available products that are coming to the market using this technology. However, the one that I work with actually uses a UL central station and trained personnel to do the targeting and controlling of the monitor. There's a couple advantages to this. One is you can be hypersensitive. You can look for very small fires. Because the UL central station is receiving this alarm and doing verification, they can actually be a filter for nuisance alarms. The other is they are better at targeting if there's outdoor conditions such as wind, and also they won't shoot at people. They'll see that there's, say, a welding event going off rather than doing a false discharge. So there's a number of advantages to using that UL central station over, say, the processing and triangulation of detection systems. FM has identified this technology, so in FM 1421, they actually have a section on automatically operated self-targeting monitoring systems, so you can actually get an FM approved system. Currently, I'm unaware of any system that is FM approved, but I do know of manufacturers that are going through the process. They also did a research project, a technical report called Reducing Water Demands with Innovative Fire Protection Solutions. So they tested smart sprinklers as well as automatic water cannons and showed that you'll actually get an 88% reduction in water usage for uncartoned, unexpanded plastic and cartoned, unexpanded plastic fire sources. So it's kind of counterintuitive because you're putting a large amount of GPM. So the system I'm going to talk about today is actually a 500 GPM solution that we're spraying water. However, you're detecting these fires, as John alluded to, you're detecting earlier, you're putting a large amount of water on, so it's kind of a sledgehammer on a nail type of scenario. So you get faster extinguishment, control. In a lot of cases, you get final extinguishment with these systems. So where are they being used? The majority of applications are actually in the waste and recycling industry. One of the reasons is there's a huge fire problem in that industry right now. This is a table done by Ryan Fogelman. He's actually sitting up here up front, who works for the Fire Rover system, which is the system that I've been working with. And you can see May 2022, which is the most recent data that he's collected, was actually the highest month of reported incident fires, and he's been collecting for over 7 years. So this is broken down by month. Over years, you can see a general trend upward. Obviously, there's a little dip during COVID. What's causing this increase in fire growth? So if you can probably guess, it's batteries. Everybody's throwing out their lithium-ion batteries in the trash that they use. They're getting crushed and mangled as they're getting transported to these facilities. When you do that, that's what causes that ignition. So this was actually from an EPA report that California looked at the causes of their fires, and 40% were lithium-ion batteries. 15 and 10 were other types of batteries, so you can almost credit 50% of the fires happening in this facility to the improper disposal of batteries. This is a video of one of these facilities where this is actually a trash to energy facility. So the tipping floor, the garbage trucks come in, dump the trash. It then gets pushed onto that left side of the video where there's a grappler that grabs the trash, feeds it into bins that go into a boiler and ignite. On the far left of this video, you'll see the red pipe going down, and then there's the monitor solution. There's thermal cameras there, and what we'll show you is what we do during commissioning to show that we'll actually get the reach. So a beacon goes off to warn people that it's gonna discharge. This is over 200 feet across in this facility. There's another monitor and detection assembly on the opposite side wall. They all have thermal cameras. Part of that is for early detection. We sometimes co-locate thermal cameras and optical flame detectors just because we want a listed detection device. And there's no thermal camera that's listed for the purpose of fire detection right now. But the thermal is also used if this bay does fill up with smoke, they'll be able to actually see through that smoke, and the operators will then be able to target that fire source. The application I'm going to talk about, and John mentioned, was the warehouse. Again, it was fitted for a sprinkler system. They put a new commodity in there. He kind of explained the issues with trying to replace that sprinkler system. So we came up with the alternative solution of using these automatic water cannons as the best alternative. When I design these systems, I always like to meet the intent of NFPA code. So if there's a hazard and I get a design density, I want to at least be providing that design density, if not greater. We had the UL report that showed that the 4 ESFR sprinklers with a K factor of 14 pressurized to 75 PSI would contain this hazard. So we wanted to match that design density. So 4, even with minimum spacing of 10 by 10, you're talking about 484 GPM or about 1.21 design density. With the Elkhart brass, our most hydraulically remote monitor, we wanted to get 100 PSI at, flow 500 GPM, so we'll be at 1.25. Now that's assuming that I'm gonna spray a 400-foot area, but our detection is actually designed to get a 1-foot pan fire. So again, we're taking that sledgehammer approach. So this was the system design. We didn't cover 100% of the warehouse. We were just covering the commodity. So we have actually 2 riser systems. You can almost call it a north system and a south system. So it's designed similar to a sprinkler system, except our piping is a little bit larger. We do hydraulic calcs to our most hydraulically remote. And what we're doing for coverage area is actually a 100-foot radius. So our monitor, even though it can spray farther than 100 feet, we're limiting that to 100 feet. We're getting a lot of cross coverage with the way that we laid this system out. I'll go a little more into design. So one thing that we want to ensure that we are going to cover the area suppression-wise. So we look at the manufacturer's specifications sheet. For this one, 500 GPM at 100 PSI and an angle of deflection of 32 degrees, we can get 150-foot coverage according to the manufacturer's spec. There's an older report by the National Board of Fire Underwriters, and that kind of confirmed the same thing. 100 PSI, 32 elevation for 1.5, 2 inch, you're about 130 to about, I think, 172 feet. So 130 to 172 feet of coverage. Again, we're only doing 100 feet, so we're being rather conservative with our design. So the solution for this warehouse ended up being 29 Elkhart Brass Nitro HD fire monitors. They all have electronic valves. It's actually a dry pipe system. So we open a deluge valve, flood the piping, and then each individual monitor, the operator can open up that monitor head and flow water. There's 58 FLIR thermal cameras, 29 cameras, visual cameras for just aiming purposes on each of the nozzles. 58 reference cameras that actually have video analytics for flame. So we've really covered a lot detection-wise to notify the operators at the central station that there's an issue going on. There's 16 sirens and strobes. These aren't for notification around the building to empty the building. These are rather that this nozzle is about to discharge and warn people around there that you're gonna get a discharge of the nozzle. We got 6 control panels with pull stations, and then there's network servers and video storage. Go a little bit more into the design. So each of these 100-foot radius, 200-foot diameter circles has 2 monitors on it. So each one covers 180 degrees. And the good thing about the warehouse is the racks only went out about halfway. Obviously, if the racks went full ceiling and you had tighter, narrower aisleways, you would have had to then space out these monitors and detection a little bit differently. But we actually had a pretty clear field of view above those racks. This is just a little closer of the setup, so you can see the 2 monitors on each side of the pole. You've got the beacons, you've got cameras, FLIR cameras, and optical flame detectors all on each setup. They go back to this panel, which is, you can call kind of the brains of it, you know, with also the UL central station monitoring. They always have a heartbeat to the system. They check in on the system, so a lot of the inspection, testing, and maintenance, we follow the NFPA guidelines, same as you'd see in 72 and for sprinkler system. So the good thing about this system too is there's a monthly charge by the manufacturer, and what that covers is not only the monitoring of the system, so the UL central station and those operators, but they do inspection, testing, and maintenance, and they have a warranty on the system. So if you've got a monitor that breaks, or you get a thermal camera that breaks, the manufacturer goes, swaps that out, so it's always up and running as part of that monitoring fee. What I thought was impressive numbers, being in the industry for 20 years, so they actually gave me the data for a 6-month period from 2021 to June of 2022. This is 253 systems that they have out in the field. Again, a lot of these are in the waste and energy facility, or the waste and recycling facilities. So of those 253, they had 758 confirmed events over a 6-month period. So each system's averaging 3 detection of actual fire events. So you think of a fire system, that's a pretty busy fire system getting positive detections. A lot of them are very small, so they have incident fire brigades at these facilities. They'll go in with a backloader and pull that fire out. They'll go in with extinguishers. So 57 of them is ones that Fire Rover actually reacted to and then suppressed that fire. Of those, I'd say over 50%, or the data showed that over 50% of those didn't need manual intervention for final extinguishment. So of over 50% of the fires that they discharge to, they'll actually get extinguishment on those fires. Here's an example of one. So this is the same one that we designed and commissioned that we showed the video. So what you're looking at here, the top right is your thermal. So you can see there's a little hotspot. That's actually gonna be on this camera, is the one that's actually gonna put that hotspot out. You can't even see it visually. In a little bit, you'll see it pop out because it's actually seated a little bit underneath that trash. And so there's 3 of these systems in this that cover this whole trash kind of area where the grappling hook goes in, grabs it, and dumps it into the bin. So this would be one where they'll get final extinguishment. I mean, it was kind of shooting fish in a barrel, right? You had 500 GPM right under a pretty small fire. So I'm just gonna hit on this real quick. We're doing one for a chemical plant too. It's gonna be installed in the spring, but overlooking tank farms and processing areas, which is gonna be foam systems. So we'll design this and then we'll actually do install in the spring. So in conclusion, these automatic water cannons, they demonstrate a faster detection, so you get notification times to the occupant, the central station, the fire department very quickly. John mentioned it's about half the time of the ESFR sprinklers. So that means you're getting smaller fire sizes at detection, so the activation results in higher final extinguishment using these automatic water cannons. The nature of the operation these are going to, the trash facilities really lend themselves to 18A agents that break the surface tension, can go into those deep piles. And then obviously if you're looking at chemical plants and flammable liquids, you've got foam. Targeting fire suppression provides the remote operator the ability to reduce false discharges and nuisance alarms, and then the increased design density that we use because of, we can design it anywhere from 100 GPM up to 500, results in increased suppression onto the smaller fire sources. So with that, I'll take any questions.
We got time for quick. We'll make it quick.
Good. Mila.
Yeah, thanks. Thanks for the presentation. Really interesting. So there's just a lot of data processing, right? So from these cameras, right? They're detecting the fire, they're triangulating this information, and then they're, if I understand correctly, they're also then going to direct where the nozzle sprays, and then potentially even influence the spray characteristics, right? So I think all this is being done through some panel, like it's.
Well,
what's the
not
evaluation of, and I could have that wrong, but.
Yeah.
But the base question is there any evaluation, i.e. a listing for that data processing system, right? There just seems to be so much tied into this.
Yeah, so there are systems, like I said, we developed one for the Royal Navy that did that processing. The systems I'm installing actually go to a UL central station, and there's trained operators that see that video, see that thermal, and they actually steer the camera. So it's almost like, I have the analogy, I use the analogy of, you know, the Air Force has these guys in outside of Vegas, and they're stealing, you know, piloting drones halfway around the world. It's the same kind of thing. So there's 3 redundant central stations. To answer your question, yes, FM has, they've created a section where you can get those systems FM approved for the purpose.
So it sounds like somebody's actually at the central station, they're actually controlling the operation.
Yeah, they're controlling the operation, and vice versa. The systems that would use the triangulation and do the computer analytics and deflection elevation, that would be covered under the same standard, the same FM standard.
Thank you, everybody.
Thank you.